This time we have a non-linear inequality. In fact, if we were to multiply this out, what we would have is a quadratic expression on the left. Now, in order to deal with this, we're going to have to think about the fact that this product, this is being multiplied together, so it's like an A times a B. This product is supposed to be greater than or equal to 0, which means positive. Greater than 0 would mean positive. So let's think about what happens. If A is positive and B is positive, then we would have a positive result when we multiply them together. If they're both negative, if A is negative and B is negative, then the result would be positive. When we multiply two negatives together, we get a positive result. But if they are opposites, if A is positive and B is negative, or if A is negative and B is positive, either way, we would wind up with a negative product. So we're multiplying two things together, and what we want is a positive result. That is what is desired here, because this says greater than or equal to 0, meaning positive. So here's what we're going to do. We're going to map out the values, or the sign anyway, for the value of these expressions x minus 8 and x plus 4 over the entire number line. And we'll start doing that by finding, well, where are they 0? Where is x minus 8 0? It's 0 when x is 8. If x is 8, x minus 8 is 0. So I'm going to line that up. If I plug 8 in for x, I'm going to have 8 minus 8 or 0. So I'm going to line those up, the factor x minus 8 and the value 8 on the number line. And then I'm going to think about, well, what is the value of the expression for other values of x? So like, for instance, if I were to put 0 in for x, I'd have 0 minus 8 or negative 8. So in other words, a negative value. If I were to put 5 in for x, 5 minus 8, that'd be negative 3, so a negative value. And as a matter of fact, anything less than 8 would make this expression negative. Anything greater than 8, like say 9 or 10 or 11, if I plug those in for x, I'd wind up with a positive value for the expression x minus 8. Now let's do the same thing for negative 4. X plus 4 is 0 when x is minus 4. It would be negative to the left of that. If I plugged in something like minus 5 or minus 6 or minus 7 in for x here, this expression would have a negative value. But if I plug something bigger than negative 4, like say minus 3 or minus 2 or minus 1 or 0 or 8, I would wind up with a positive result for that expression. Now, what we might notice then that we have done is we've broken the number line up into 3 parts. The part between negative infinity to minus 4, and then the part from minus 4 to 8, and then the part from 8 to infinity. And in this part here from minus infinity to minus 4, both of these factors have a negative value. And when I multiply them together, when I multiply x minus 8 and x plus 4 together, when they both have a negative value, that result would be positive. If they're opposite, that result would be negative when I multiply them together. And when I multiply them together for any value of x greater than 8, they're both positive, and I would wind up with a positive result. Now, what were we looking for? We were looking for where this product is positive. In other words, this region in here where both of these expressions have a negative value, or this region over here where both of these expressions have a positive value. So my solution set then is going to be everything from minus infinity up to minus 4 with a parenthesis at minus infinity and a bracket at minus 4. And I'm going to put a union, or, means the same thing. And I'll start back up at 8 and end at infinity. So my solution set then would be everything from minus infinity to minus 4, including minus 4, because that would make this product 0. And then everything from 8 to infinity, including 8, because 8 would make this factor 0. And when I multiply it by whatever this winds up being, I would still wind up with 0. Here we have another nonlinear inequality, and it is quadratic. This time we'll need to factor it first. And so we'll have x plus 5 times x plus 3 when we factor, and that's supposed to be greater than 0. So we'll do the same thing. We will map the values of x plus 5 and x plus 3 over the number line. X plus 5 is 0 when x is minus 5. So we'll put a 0 that lines up this factor, x plus 5, with this value, minus 5. X plus 3 is 0 when x is minus 3. So I'll put a 0 that lines up x plus 3 with this value, x minus 3, on the number line. And this time, again, we've broken the number line up into 3 parts. And if I think about this factor, x plus 5, if I plug values of x that are less than minus 5, like say minus 6 or minus 7 or minus 8, in for x here, I would wind up with a negative result. If I plug anything in between minus 5 and minus 3 in for x here, like say minus 4, I'd wind up with a positive result. And the same to the right out here. If I plug anything bigger than minus 5 in for x in x plus 5, I'll wind up with a positive result. Now, x plus 3 will be negative to the left of where x is minus 3. Like, for instance, if I plug minus 4 or minus 5 or minus 6 in for x, x plus 3 will have a negative value. And if I plug anything greater than minus 3 in for x, like, say, 0, I'd have 0 plus 3 or positive 3, or in other words, a positive value. Now, what are we doing? We're multiplying these things together. And when we multiply two negatives together, we wind up with a positive result. And when we multiply opposites together, we wind up with a negative result. And when we multiply two positives together, we wind up with a positive result. Now, what were we looking for in the first place? We were looking for where this product would be positive, greater than 0. Okay, well, we found that. It happens from minus infinity to minus 5. And this time parentheses in both spots, because this only says greater than. It doesn't say also equal to, so we don't include the endpoints. And then we would say union or, means the same thing. And then it starts up again at minus 3 and goes to infinity with parentheses. So here is our solution set. Any value of x in this set or in this set would make this quadratic expression positive or greater than 0. Here we have another quadratic inequality, but this time we don't have 0 over on the right. And that's the thing that we use, the fact that anything to the right of 0 is positive and anything to the left of 0 is negative on the number line. So what we have to do is make sure that we have 0 on the right. So I'm going to subtract 3x squared from both sides, and I'm going to subtract 5 from both sides. And we'll wind up with 2x squared plus 9x minus 5 greater than or equal to 0. So what we'll need to do here is factor. And so we'll have 2x and x. And we will have a plus 5 here and a minus 1 here so that we can get this minus 5 product. And if we multiply this out, we'll have 2x squared plus 9x minus 5. So we'll do the same thing again. We will map 2x minus 1 and x plus 5 over the number line. And 2x minus 1 is 0 when x is a half. And x plus 5 is 0 when x is minus 5. So we line up our zeros again. Show how we have the number line broken up. And then map our sign. 2x minus 1 is negative to the left, positive to the right. X plus 5 is negative to the left, positive to the right. And then see what we have here. We have two negatives, and when they're multiplied together, as we have here, that result will be positive. If we have opposites multiplied together, that result is negative, and if we have two positives multiplied together, that result is positive. So our solution set then, this says greater than or equal to 0, including 0, so we'll include the endpoints this time. So our solution set will be minus infinity up to minus 5 with a parenthesis and a bracket, and then it'll start up again. We can say union or either thing. 1/2 to infinity, including 1/2 and not including infinity.